Today I'm going to describe how to use the PASCO electric field conductive paper for an electric field mapping activity. You can get the kit. It comes with this nice board, which I think if I used it more, if I didn't have such large classes, I could use that for the pinning process that you're going to see. But otherwise, it comes with a whole bunch of this black conducting paper. Comes in a large pack like that. That's what it looks like, sort of. And it comes with one of these pen sets. I've used this for a long time and my other pen dried up, so it's a silver conductive ink pen that you can get here. I've already created some of the papers, some of the conductive paper, but this has a high resistance to it, but it is conductive. I've made a funny looking one here with an empty hole in it. But on all these you're going to see this silver ink that I've drawn on. I made just several patterns out of it. This might represent a single charge, and the electric field will end up going outwards from it. The pattern we're going to see here be from a positive side to a negative side, so this might represent a capacitor. There's a smaller width capacitor. This one might represent, I'd hook it up with a pen here and a pen here and connect those two to the positive pole of a battery, as you're going to see for the setup, and connect the outer border to a negative. So this would simulate like two positive charges close together in the field that they would produce around it. That works nicely. This one is just a positive and negative. I hooked up one side to the positive pole of the battery, the other side to the negative, and creates a nice pattern in between the field. So I just have a selection of those patterns. Instead of using that cork board that comes with the set, I just use like a cheap rip-off piece of cardboard, and you can simply take the conductive paper, put it on that. Cardboard just gives something to push the pens into, and the kit comes with metallic pins that you can put right in. Now it's important when you put these in to find a metal part that hasn't been used yet. You can see this one's been used quite a bit. So you create the electrode, make sure that gets pushed into the metal part of the ink. And over here, I'll try that one out. Now this video, I'm not going to actually demonstrate and get numbers from it. I'm just describing the setup. And what I'll do from here is connect using some alligator clips. Connect one side of the positive terminal of a D cell, or actually a 6-volt lantern battery works great for these because they just sit up there and they're easy to connect to. So I really recommend the 6-volt. Connect one side to the positive, the other side to the negative. And now for actually collecting the data and finding the direction of the field, you need to, I like taping the two probes together, and what that gives is a set width or distance. And I guess the idea would be that as you're moving further away from that electric field source, the difference in potential between the two sides, difference of electric potential, will decrease as you get further and further away. So keeping that constant distance helps you to figure out the intensity of the field at those 2 points. In this activity, we're not really looking for intensity, we're just looking for direction. So connecting those two together, hooking into the voltage side, and your multimeter will probably look a lot different because they come in many varieties. If I've got a 6-volt lantern battery set up, I'm not going to set the 2, probably set it to 20 for my max. Make sure I'm on DC. And the way you'll do this, just describe to the students, is to pick a point on the plot and put one of those sides down, and then put the other side on the paper, and then just rotate, and what they're going to see is the values on the multimeter changing, and the direction, because it's electric potential in itself is not a vector, so the greatest difference is what we're looking for. And that will give you the direction of the electric field vector. So we're actually, these measure the magnitude of the, I guess, the electric field strength. What we're looking for is the direction. So you get that direction by rotating until the student's going to find the greatest value. So they'll probably pass the value, and the values on the multimeter will start to decrease. So once they pass it, tell them just to kind of rotate back in order to find where that is. On their paper, I'll have them just plot an arrow. So their paper looks exactly like their drawing paper looks exactly like the conductive paper. Of course, it's made out of white paper instead. So I have them find that grid point and draw an arrow in the direction of that greatest potential difference. And that's how these work.